For this video, I will discuss on Math 9 Module Quarter 3, Week number 2. So, week number 2 is about special parallelograms. So, let's go directly to the lesson. So, as you can see in your module there, you have the three types of special parallelograms. First is rhombus, then rectangle, and square. So, these are the three special parallelograms. So, rectangle, rhombus, and square are quadrilaterals that are parallelograms. They are known as special parallelograms. They are special since all the properties of a parallelogram are present in square, rhombus, and rectangle. So, let's have first the characteristics of rectangle. Okay, first one, opposite sides are parallel and congruent. So, when you say parallel, if we're going to extend the sides, they will not intersect. Okay? So, they are parallel and congruent. So, congruent means they have equal measurement. Second one, opposite angles are congruent and supplementary. Supplementary, if you're going to add the two, the total will be, or the sum will be 180 degrees. Number 3, all four angles are right angles, meaning the measurement is 90 degrees. 4, consecutive angles are supplementary. So if you're going to have MATH, M and A, they are consecutive, A and T and H and M, they are consecutive. So meaning for number 4, they are supplementary, meaning the sum of the two angles is equal to 180 degrees. 5, diagonals bisect each other and are congruent. So if you're going to draw diagonal here, HA and MT, they bisect each other, meaning vertical angles are congruent and they are congruent, equal measurement. 7, each diagonal separates the rectangle into two congruent triangles. So if we're going to have rectangle MATH, if we're going to draw a diagonal here, HA, so this one will divide the rectangle into two congruent parts. So this will be the triangle number 1, and below will be triangle number 2. Then let's have theorem number 1. So if a parallelogram has right angle, then it has 4 right angles and the parallelogram is a rectangle. So let's go directly to the given example here. Use rectangle MATH and the given information to answer each. So given rectangle MATH with the point of intersection of the two diagonal as point S. This one here. Now given if measure of angle MAH is 25, so this one is 25 degrees. Find the measure of angle HAT, angle THA, and measure of angle AHM. So for our solution, since parallelogram MATH is a rectangle, so we can say that measure of angle MAT is equal to 90. So this angle here is equal to 90 degrees. And since the given MAH, this angle here is 25 degrees, so it will follow that angle HAT, this angle here, is 90 minus 25. Okay? So this is 90 minus 25. So the answer will be 65. This is the measure of angle HAT, the angle here. Then solving for letter B, since parallelogram MATH is also a parallelogram, angle MAH and angle THA are congruent. Therefore, measure of angle THA is 25 degrees. And for letter C, find the measure of angle AHM. AHM, this angle here. Okay. So if this is 25 AHT, 25, so angle AHM is just 90 minus 25 and also equal to the measure of angle HAT, which is 65 degrees. Then let's have theorem number 2. The diagonals of a rectangle are congruent. So if we're going to have rectangle MATH here, we can say that line segment MT and line segment HA are congruent. So let's go directly to the example. So parallelogram math is a rectangle. Find the value of x and the specified sides. So number 1, if line segment MT, diagonal MT is equal to 5x minus 14, HAA, line segment HA is equal to 4x plus 6, find A, x, B, line segment MT, and C, line segment AS. So for our solution, since the two are equal, we can have line segment MT equals HA because they are diagonals and diagonals are congruent or they have equal measurement. So we can have 5x minus 14 equals 4x plus 6. So combining like terms, transpose 4x to the left side, it will become negative 4x. So we're going to have 5x minus 4x. Then transpose negative 14 to the right side, it will become positive 14. So 6 plus 14. 5x minus 4x is equal to x. And 6 plus 14 is equal to 20. So x here is equal to 20. Letter B, since x is equal to 20, then we're going to find line segment MT, the measurement of line segment MT. So we're going to substitute x in 5x minus 14 with 20. So we're going to have 5 times 20 minus 14. So 5 times 20 is equal to 100. Then 100 minus 14 is equal to 86. So MT is equal to 86. Then letter C, find line segment AS. Now, MT is equal to HA. So we can say that HA is also equal to 86. And AS is half of AH. So we can say that AS is 86 divided by 2. So line segment AS or AS is equal to 43. Now let's go to the characteristics of rhombus. Number 1, all 4 sides are congruent. So if we're going to have the rhombus here, this side here, this side, and this side are congruent or they have the same measurement. Then opposite sides are parallel. So FR is parallel to NE, FN is parallel to RE. Again, parallel, they will not intersect if we're going to extend the segment. Number 3, opposite angles are congruent. So angle R is congruent to angle N, and angle F is congruent to angle E. Number 4, consecutive angles are supplementary. So the same with the rectangle, consecutive angles are supplementary, or again, their sum is equal to 180 degrees. Number 5, diagonals bisect each other and are perpendicular. So if they bisect, just like this one, they are perpendicular, meaning each angle made will be equal to 90 degrees. Okay, so this one is 90, 90, 90, and 90 degrees. Number 6, each diagonal bisects a pair of opposite angles. So if you're going to have this rhombus here, so this line segment or this diagonal FE bisects angle F into two congruent parts, and also it bisects angle E into two congruent parts. And if we're going to have this diagonal RN, it bisects angle N and angle R into two congruent parts. 7. Each diagonal separates a rhombus into two congruent triangles. So just the same with a rectangle. So let's have theorem number 3. The diagonals of a rhombus are perpendicular. So if we're going to have this rhombus here, now the two diagonals here form a right angle. This one, 90, 90, and 90. Okay? So that's the first theorem on rhombus. Now let's go directly to the example. So parallelogram FREN is a rhombus. Find the missing value using the given information. Number 1, if line segment RN is equal to 20 centimeters, find line segment ND. Number 2, if measure of angle NDE, this one here, is equal to x squared plus 65 degrees, find x. Okay? So for solution number 1, since rhombus is a parallelogram, each diagonals bisect each other. Thus, if Rn is equal to 20 centimeters, we can have ND as its half. Okay? So 1/2 of Rn. So 1/2 of 20 is 10. Therefore, ND is equal to 10 centimeters. Now, let's have number 2. The diagonals of a rhombus are perpendicular. Thus, angle ND is a right angle, or its measure is equal to 90 degrees. So, we can have this one, x squared plus 65 is equal to 90 degrees. Okay? Then transpose 65 to the left side, that will become 90 minus 65, and that will be equal to 25. So x squared is equal to 25. Then extracting the square roots, square root of x squared is x, square root of 25 is 5 or negative 5. Now since we're talking about measurement, so we can have the value of x as 5 degrees. Theorem number 4. Each diagonal of a rhombus bisects opposite angles. So given parallelogram FREN is a rhombus. So in here, Rn is a diagonal. This one. And it will follow that this diagonal bisects angle N and angle R. So we can have angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. Let's go directly to the example. FREN is a rhombus. Find the missing value using the given information. So in the figure here, you have the numbered angles, angle 1 to angle 9. Number 1, if measure of angle 1 is 33 degrees, find the measure of the other numbered angles. Now, since each diagonal of a rhombus bisects opposite angles, therefore, measure of angle 1 is equal to measure of angle 2 as well as measure of angle 3 and measure of angle 4. So, since angle 1 is 33, so it will follow that angle 2 is 33 degrees. Same with angles 3 and angle 4. So, they have equal measurements. Now, since the diagonals of a rhombus are perpendicular, therefore, measure of angle 5 is 90 degrees. E. Since measure of angle 1 plus measure of angle 5 plus measure of angle 6 is equal to 180 degrees, so we can say that measure of angle 6 is equal to 180 minus measure of angle 1 minus measure of angle 5. Then adding the two, 33 and 90, that will be 123. And 180 minus 123, that will be 57 degrees. So measure of angle 6 is 57. And since measure of angle 6 is equal to measure of angle 7, angle 8, and angle 9, therefore, they have the same measurement, which is equal to 57 degrees. Next one, characteristics of square. Number 1, all four sides are congruent. 2, all angles are right angles. 3, opposite sides are parallel and congruent. Opposite angles are congruent and supplementary. 5, consecutive angles are supplementary and congruent. 6, diagonals bisect each other and are perpendicular and congruent. So this is the same with rectangle. 7, each diagonal separates the square into two congruent triangles. So the same with rectangle and rhombus. Theorem number 5, the diagonals of a square are congruent and are perpendicular. So we're going to have our square here, BEST. BS is congruent to ET and BS is perpendicular to ET. So all of the angles here inside measures 90 degrees. Example, parallelogram BEST is a square. Find the missing value using the given information. Number 1, if YE is equal to x plus 5 and BS is equal to x plus 25, find TE. Number 2, if measure of angle SYT is equal to 4x plus 10, find the value of x. So for our solution, for number 1, line segment TE is equal to line segment BS. So reason for this one is diagonals of a square are congruent. Now, TE is equal to twice YE. Therefore, in our next solution, we can say that TE, we can substitute that one with x plus 25. And we can have BS as twice of the measurement of YE, which is 2 times the quantity of x plus 5. Then, solving this one, twice x plus 5, so 2 times x is 2x. Then, 2 times 5 is 10. So, we are going to have 2x plus 10. Then, combining like terms, 2x minus x equals 25. Transpose 10 to the left side. This will become minus 10. So, 25 minus 10. So, we can have x equals 15. Therefore, TE is equal to x plus 25. Substitute x by 15. So, we can have 15 plus 25. So, TE is equal to 40. Number 2, since line segment TE is perpendicular to line segment BS, then angle SYT is a right angle. So, we can have measure of angle SYT equals 90. Then, substituting measure of angle SYT with the given 4x plus 10. So, we can have 4x plus 10 equals 90. Then, transpose 10 to the left side or to the right side. This will become negative 10. So, 90 minus 10. So, our answer will be 4x equals 80. Then divide both sides by 4, x is equal to 20. So those are the characteristics of the three special parallelograms: rectangle, square, and rhombus. So you can use those given characteristics and theorems in solving the next activities. So that's it for this video. Thank you for watching and see you next time.